few words from Dr. P. Nityananda on behalf of OWASP chapter.
Good morning. Is it audible?
Yes, sir. Yes.
Yes, sir. Yeah.
Good morning, everyone. More particularly, Mr. Lakshit Madan, who is the resource person from Blockchain Unmasked. So I welcome you on behalf of VIT Chennai campus and this sharing forum to share your immense knowledge to the student community. We're thankful for the same, sir. So I welcome you all to Block Talk, a webinar conducted by the students of OWASP student chapter. VIT was established with the aim of providing higher quality education on par with international standards. For Block Talk, we have speakers from various prestigious industries. I hope everyone present here learns and gains beneficial information from all the sessions. So with respect to blockchain, I give a small intro about that. So it's in need of the hour, and of course, need of the cutting edge technology where every student has to expose into the technology. So very few institutions and of course other renowned institutions across the globe only had taken that as academic part and that's brought inside. So the new thing or innovative thing on the technology is a distributed ledger. So where a centralized system only we follow for authenticity and integration or authorization. Whereas this is something new where distributed ledger is actually adapted in that blockchain technology. And of course, they try to bring in decentralized consensus over the system. So getting a consensus over a decentralized system is really a tough task, and of course, implemented that. And of course, that is the need of our for plenty of communication where people and actors who are geographically distributed across the world, they need to take a consensus with their decentralized setup. So through blockchain technology, certainly they're achieving that, of course. So we have an opportunity to get this from the renowned industry people who have their live experience, who actually are practicing in their life through the blockchain technology. So it's a nice opportunity for us to hear his lecture. With respect to application, you are aware that student community, so blockchain has various vast application with respect to secure sharing of medical data and music royalties, even tracking, even cross-border payments and cryptocurrency exchange, anti-money laundering tracking system, supply chain and logistic monitoring, sometimes even smart contracts where Kickstarter, crowdfunding, and of course, such people will use to do that. And advertising insights where it has a very huge market, and of course, even original content creation. And very particularly nowadays, government started using in all the real estates in the case of e-governance. So the application is abundant. Of course, it's not limited to this scope of this lecture. So with this small introduction about this system, let me just call upon Mr. Lakshit Madan, of course, who will be introduced by our OWASP coordinators. And of course, I thank for the opportunity as given to introduce about this chapter, and also I welcome all the participants who had given the session. I hope the fourth session which we are planned will be give you a good insight on blockchain technology, and of course help going to a lot. So stay safe, stay healthy, and of course thanks for your presence. Thank you.
Thank you for a kind words, sir. Now, today we have our chapter leader, Mr. Sparsh Raj, also with us, who is the backbone of this chapter, and I request a few words from him.
Good morning, everyone. I'm Sparsh Raj, the chapter leader of OWASP VIT student chapter. I welcome you all to the Block Talk event. Hope you all have a great session. We have our first speaker waiting for his session to start. So let's not make a delay and get it started. Thank you, everyone.
Thank you, Bhaiya. Like you said, without further ado, let's get started with the session. Our first speaker of the day is Mr. Lakshit Madan, founder of Blockchain Unmasked. He has various publications and projects under his name and has worked in the field of web development and blockchain for more than 2 years. Now, over to you, Mr. Madan.
Thank you. Hi, everyone. So that was a good introduction of mine. Thanks a lot. So yeah, so let me just give you a brief introduction of myself again. So guys, I started blockchain 2 to 3 years ago when I was graduating, and I recently graduated. I completed BTech in computer science from GGS IPU. And during my graduation, like I have worked on various research papers and articles which are published into IEEE in Springer, and they are all related to blockchain with other domains such as machine learning, IoT, etc. Plus, like after my graduation, I started with Encrypt Labs, and Encrypt Labs is basically, you can say, we are into service industry, and we provide blockchain solutions, whether it is content development solutions to blockchain or smart contract development, front end development, etc. Plus, we have our own educational vertical named as Blockchain Unmasked. So what Blockchain Unmasked do, we basically curate educational content for people like you who are blockchain enthusiasts, or who are like very interested to get into Web3 and Web3 and blockchain industry. So further ado, so let's start with the session. Uh, Also, like just a second, like I have to take the screenshot. Okay, so yes, let me share my screen. So is my screen visible to all?
No, sir.
No, sir. It's not visible.
Okay, okay, just a second.
Yeah, it's visible now, sir.
Your screen is visible. Is it audible, sir?
Hello.
Sparsh, is it audible?
Yeah, I'm audible
No,
now.
sir. No, sir. No.
No, you
Hello.
are not
Lakshit, I
audible,
guess you
sir.
are muted.
Hello.
Yeah, Lakshit. Now you're audible. Yeah.
Okay, okay. Actually, I was not able to mute myself. It was coming something else.
Okay, no problem. No issues.
Okay, so let's coming to the table of contents for today. So intro to blockchain technology. So first we'll be discussing about a brief introduction about the blockchain technology, then moving to the working, and then to the architecture of the blockchain technology. So just coming, just a second, guys. Just a second. Something is coming up on the presentation. Just a second. Yes. So now moving to the brief introduction to the blockchain technology. So in layman words, what we can say, blockchain is basically just a chain of blocks. Is the audience comfortable with Hindi? If I may speak in
Better
Hindi,
to
or
go with English. Better to go with
okay,
English. We have a wide variety of audience, please.
okay, no issues, no issues. So so as I said, like blockchain is just basically a chain of blocks, or we can say it's just a database. But but the database, in mostly cases, both the databases are in a centralized nature. But blockchain is distributed and it is decentralized in nature. It is basically a distributed ledger that that facilitates recording sessions and keeping the track of assets in in a network. And and when it comes to the transaction can be anything. A transaction can keep what I mean is transaction can keep a record of anything. Any data can be stored in the form in that form of transaction. So coming to the properties of blockchain technology, blockchain is transparent. Transparent, which means, as I said, it's a distributed ledger. So all the transactions are visible to everyone. It is transparent. Anyone can see the transactions, and it is immutable. Immutable C means whenever a transaction happens on blockchain and it is stored on the blockchain, it cannot be reversed. Once it is stored, it is stored. So no one can tamper with the transaction. That means it is immutable. Plus distributed, it is distributed all over the world. It is decentralized and distributed with the what we can say with many entities which are also known as nodes and miners. So that makes this technology distributed ledger technology. Plus, when it comes to security, it is one of the secure technology we see. So now coming to the working of blockchain technology. So as we are seeing here, there are three blocks, right? As I said, blockchain is basically chain of blocks. So this is we can say a sample diagram of a blockchain. So in the blockchain, the first block is always known as Genesis block. Then comes the block 2, block 3, and so on. So each block contains some values such as the hash of the block, the previous hash, and the data. Data, as I said, data can be anything. Data can be a JSON file. Data can be a metadata of a metadata of anything. Like it can be anything. But the data is encrypted whenever it is stored in the blockchain. So previous, as you can see in the Genesis block, the previous hash is 000 and the current hash is 023 and ABED4. And when it comes to block 2, so as we can see here in block 2, block 3, all these hash values are combined with each other. So what happens is each block contains the previous hash of the previous block. So this is how the chain is connected with each other. And uh, when it comes to the tampering part, whenever a hacker or someone tries to tamper with the chain, if he tries to suppose if I come and if I try to change the hash value of this block 3, so automatically all the hashes will change, and that's how no one can try to tamper with the chain. So this is one of the main major feature of blockchain that we call is that is the security. That's how blockchain is secured. Plus all the data, as I said, it is stored in the encrypted form. The data, basically what happens is whenever the data is stored, we use some certain cryptographic hashing algorithms such as SHA-256 algorithm, Keccak-256. So these algorithms are used to encrypt the data, to convert the data in the form of hash value so that no one can decrypt it easily. Next, coming to the architecture of blockchain technology. So, so as I said, blockchain is a decentralized has a decentralized architecture, right? So, no. So, what happens in central authorities? There is some central authority to govern any architecture. But when it comes to blockchain, there is no central authority. The architecture is decentralized. It is open to all. Anyone can participate. Anyone can participate in the blockchain. So keep coming to the so one more thing I wanted to add in this. So as I said, what makes the architecture distributed is like there is a network of millions of computers which we commonly known as nodes or miners. So these nodes are like sitting in the these nodes, and all these network is connected to each other. So that's what make this a distributed architecture. Now coming to the key architecture characteristics of blockchain technology. So blockchain technology has some key blockchain architecture has some key characteristics. The first one is cryptography. So cryptography, as I said, cryptographic algorithms, hashing algorithms are used to make that they are also used for verifying the transaction, whether the transaction happened is authentic or not. Plus, whenever the data is stored in the blockchain, uh, to uh, to convert the data into hashing algorithms. Next comes the immutability. So immutability, as I said, immutability, whenever a transaction is recorded on the blockchain, it cannot be reversed. It is immutable. Provenance. Provenance basically means whenever a transaction happens, we can. It means if we are looking at the transaction on the ledger or on the table, we can. It is possible for us to trace back to the origin, because whenever a transaction store uh, there also comes the address through which the transaction happened. That becomes easy for us to keep the possible trace of the transaction. And in the decentralized, as I said, the architecture is decentralized, means there is no central authority to govern on the architecture. The architecture is open to all, and unlike centralized system, there are consensus algorithms which are used for managing this decentralized architecture. Transparency is that uh, uh, whenever the transaction is stored on the blockchain, and suppose if there are two entities, A and B, and they want to and they said the transaction, suppose A sends some amount to B, right? And A says what is the transparency of the transaction which you made, is it legitimate or not? So B can show the ledger. So that's how the transparency can be maintained between two parties. So that's how we can say the transaction happening on the blockchain are transparent, and it's open to all. Anyone can look at it. So like no one is making fool out of anyone. So this is how, as I was saying, the architecture of the blockchain. That's how a centralized architecture look like, and this is how a decentralized. But blockchain is basically a decentralized and distributed. So the dots here are basically what we can say, the nodes or the computers, which, as I told, these are connected to each other. So they are making a network, and that's how a distributed architecture is made. So coming to the components of blockchain architecture. So there are many components in the blockchain architecture. The first one is, and the first important one is node. So node basically is an independent entity. We can say an independent entity in the chain. Nodes are basically the computers which are sitting in any corner of the world, and and these network of nodes, what we can say, make the chain, and they maintain the chain properly. So next come the transaction. Transaction is basically the data or the record which is stored on the blockchain. And it whenever a transaction is added to the chain, you can say a block is added to the blockchain. So, and as I said, like each transaction contains a data. So next come the block. So block we can is basically similar to transaction only. It is a data component that contains the hash code of the block, the previous hash code of the previous block, and the timestamp of the transaction, or plus and the data. So timestamp is also one thing which is stored in the block. Timestamp refers to the time at which the block was added to the chain, which is the sequence of the blocks. miners are basically the nodes, as the nodes which are the computers that validates the block. So what happens is, like, whenever a block has to be added to the chain, so there are miners and the nodes. So miners, what basically do, miners get to solve a basic puzzle, right? So miners get to solve this basic puzzle, and the one who solves the puzzle gets to add the block, and in return they also get a reward fee for adding the block. Plus this fee is basically is rewarded them to them for adding the block, plus for managing the whole network. So next, coming to the consensus protocol. Consensus, basically in layman terms, it means an agreement. So what happened, as I said, like when the miner solve the nonce, so all the miners come to a consensus, they come to an agreement that who will get to add the block. So there are different consensus mechanisms, such as, maybe you have heard about proof of work, proof of stake consensus mechanism. Proof of work consensus mechanism is very famous mechanism, which is currently used by Ethereum and Bitcoin. And as we say, like, Ethereum is slowly moving to proof of stake, because in proof of work consensus mechanism, what is happening is uh, there is a lot of gas fees, and a lot of gas fees there. There is high network congestion. So because of that, to make a transaction happen, or to add a block into the blockchain, it requires a lot of time, plus a lot of energy is required, which is also giving a huge impact on our environment as well. Next, coming to the types of blockchain architecture. So there are two types of blockchain architecture, or we can say there are two types of blockchain, such as public and private blockchain. So what public blockchain refers to is, public blockchain is like it's like an open distributed blockchain ledger. Like, anyone can participate into it. For example, Bitcoin and Ethereum, they both are public blockchains. So like, anyone can be part of Ethereum network, and anyone can be part of the Bitcoin network. And in public blockchain, they require a cryptocurrency. The decentralization rate is very high, but the throughput is very low, and high energy consumption, as I said, because of the proof of work consensus mechanism. So proof, because that's why there is very high energy consumption, and that is like leaving a enormous impact on an environment. And when it comes to the private blockchain are mostly we can take example of Hyperledger. If you maybe heard about Hyperledger, Corda blockchain. So these are private, and they are known from another name as well, enterprise level blockchain. So what happens is, like, what mostly enterprises do, they need a private network of their own. So that's why they go for private blockchain, because in private blockchain there is no cryptocurrency required for there is no cryptocurrency required. And plus, the participants are also pre-selected. It is not open to all. No one can easily, like, participate into them. Plus the decentralization rate is very low into private, but the throughput is very high into private blockchain, because there are less because it is a private blockchain is a network of we can say less people. That's why it is high throughput, plus low energy consumption is there. Because in private blockchain, the consensus mechanism is not proof of use is not proof of work. Mostly it is proof of stake. So that was all, guys. That was the whole architecture and working of blockchain. So now let's come to this diagram and see, like, how does a transaction gets into a blockchain. So this is a flow diagram of how a transaction is happening into the blockchain. Let me explain it to you. So what happens is, whenever, suppose if I'm sitting on my computer and I'm doing coming to the first step, if I'm making this transaction. So first the transaction is requested and it is first authenticated, and then second, moving to the next step, a block representing as we can see
Yeah.
is created. So this block is
Yeah.
then sent.
Huh.
Hello. Like if someone wants to talk.
No, sir, you can continue.
Okay.
Sir, you are muted.
Yeah, I'm audible now.
Yes, yes.
Hello.
Yes, you're audible.
Okay. Okay, so coming to the next step, as I said, first a transaction is requested and it is first authenticated, and then it is then moved to a block. So then a block is the block is created for that particular transaction, and then that block is sent to the third step. The block is sent to the node, that is the each participant in the network, which are distributed. So then the node validates that transaction, that the transaction is legitimate or not, or it's just something fake. So then when node validates the transaction, node is basically the miner, you can say. So the node or the miner, they validate the transaction, and then they get their reward for proof of work. And like if the node or the miner is validating for Ethereum blockchain, they get a reward in the Ethereum cryptocurrency. Then after getting the reward, the block is successfully added to the blockchain. The network is updated and distributed across as the block or the transaction is added to the ledger, so anyone can view that particular transaction. And in the last step, we can see the transaction is complete. So that's how this is the whole step, how a block is added to the blockchain and how a transaction successfully happened.
Yeah, Lakshit, if you don't mind, can I ask a question here?
Sure. I guess
Yeah.
like we can take questions in the end. I get 2 to 3
Okay,
slides are
thank
still
you.
left.
Okay, thank you.
Okay. So that's how a transactions look like. A successful transaction looks like in this transaction is taken from Etherscan actually. So that's how a transaction on Etherscan looks like. Etherscan is basically a blockchain explorer. If no one knows about, there on Etherscan, you can search from according to a hash value or an address. You can search for a particular transaction which happened on the Ethereum blockchain. So that's how a transaction looks like. As you can see in the first, there is a transaction hash of that particular block, the status, the block name, the block number, sorry, the timestamp of the block, and from this is the particular address from which the transaction happened. And two refers to uh, two uh, two two refers to the contract through which that particular entity was making the transaction. Value refers to the value that particular person offered to this contract, that is 0.07 ether. Transaction fee is basically the gas fee only, which was paid to the miner. The gas limit, these are just these three are just basic things. Gas limit refers to, there's a firstly, like in Ethereum blockchain. So in Ethereum blockchain, there is basically a minimum gas limit, that is 21,000. So this was the gas limit of this particular chain. Nonce, as I said, nonce is that particular pattern which the node or miner gets to solve. So that's all, guys. We can take questions now.
Thank you for the presentation, Mr. Madan. As for questions, we have got a question from Arshia.
So I have a
She's
question here.
asking, won't the
Yeah, I have a question from my side, Lakshit.
Okay.
Regarding that mining you told, no. So now you mean to say that the people who do block transactions, they have to pay any extra transaction fee apart from sending money? For example, I'm
Yes,
talking with
yes. Exactly. Yes, this happens because like whenever you are making the transaction, are you aware about the concept of gas fees?
No. Okay.
Okay. So let me tell you what happens. So maybe you are aware about smart contracts.
No, I am just asking this question with respect to simply I'm sending a money in the form of Bitcoin from one party to another party. So
Mhm.
would I have to pay any additional fee? For example, I want to send two Bitcoin to some person B. A want to send to B. So how this happens? How much extra I have to pay in order to send the two Bitcoin? How much extra I should pay as a commission? And of course, how the money is circulating in the system such that the miner will get the money. We have some reward is given to money miner also. So how that money is
See
get pocket?
the transaction fees and the gas fees, it is fixed for every miner. I'm not aware about the reward fee at the moment, like what is the reward fee, but I guess in Bitcoin, it is zero point 0.1 or zero point 0.2 Bitcoin what a miner gets out of your whole transaction. So what happens is in the proof of work thing, whenever you are like suppose if you are making a transaction on Ethereum blockchain, if you want to send money to someone, right? If you are doing that thing from a smart contract, so you will be you will like if you are sending a transaction through MetaMask, right? So MetaMask is basically it is also built on a smart contract. So you will be calling some function for that. Suppose you are calling this function send, and you are sending suppose two ethers to a particular entity. So what will happen is whenever you will be sending this, they will be charging some extra fees from you that we call as gas fees. So that fees is actually used basically used for paying that reward to the miner, because that miner is basically is managing the whole network, and and the reward has to be paid to a particular miner for making your transaction successful. So that is the whole concept of paying that transaction fees, the extra fees which you have to pay. That fee, you are basically, you can say you are paying that fee for the network maintenance, or you are basically paying from your pocket, the minor reward from your pocket. That's all. That is the whole concept actually.
Mhm.
Okay, in the
Okay,
chat, I
okay.
guess there are questions.
Yes, sir. Like Arsha has asked, won't the immutability of blockchain count as a disadvantage since the certain data which is entered can't
It's
be modified or deleted?
actually we can't say it's a disadvantage because of immutability there is transparency, but generally what happens is like from a developer point of view, what happens is if you are building some NFT marketplace or some other project, it becomes difficult because somehow if we are like trying to upload some data, and we know that data can't be that data can't be deleted now. So there are some other like building smart contracts, there are some other approaches, like we use upgradable smart contracts and other features for that, like to overcome this immutability thing. So that is some whole other concept, upgradable smart contract, upgradable smart contract. So you can read about it on Google. So then you can get to know like immutability is not a disadvantage, it's actually an advantage of, it's a very main advantage of blockchain. So
I
there
hope
are the
that
questions.
solves a doubt. And Utkarsh has a doubt. He has asked like which one should we choose, Solana or Ethereum?
Okay, so Solana and Ethereum, they are totally different. Ethereum, Solana is basically an enterprise level blockchain. As I said, like while explaining about public and private blockchain, Ethereum is a public blockchain. So Ethereum currently uses proof of work consensus mechanism, right? As I said, and there are many disadvantages coming with the proof of work consensus mechanism, because uh, uh, because of like as I said, high network congestion, higher gas fees price. But Solana is something different. Solana is an enterprise level blockchain. It is something more what we can say similar to private blockchain. It not uses proof of work consensus mechanism. I guess it has they have their own consensus mechanism. I just forgot the name at the moment. Let me check. Solana uses is Solana, I guess, uses Tower BFT and uh, mm, they have their own consensus mechanism. Just a second. Yeah, PBFT. It is proof of history consensus mechanism. Actually, apart from proof of work and proof of stake, there are other consensus mechanism as well. Like many new chains are coming up with their new consensus mechanism. They are trying to solve this issue of high network congestion and the time which is taking for making the transaction fee. So as compared to see like if we are building an enterprise level thing, if we want to build some enterprise level thing, we should actually go with Solana, because Solana is best for building enterprise level solutions. And if we are going with building an NFT marketplace or something related to public, then we could go with Ethereum. But there are other layer 2 solutions as well, such as Matic, Arbitrum. Um, through which instead of deploying your contract on Ethereum, you can use them. You can use Matic or Ethereum for like because in Matic they are more secure. The network congestion is very less. The even the gas fee is very less. In Ethereum, I guess the gas fees is 6 to 700 rupees, but in Matic, I guess it is 10 paisa or 20 paisa. So I like you can see there is a huge difference between this.
All right.
So
I think that's also the again. And Gautam has asked for your opinion on Polygon network.
so as I said, Polygon Matic, yeah. So Polygon is basically a layer 2 solution built on Ethereum virtual machine only. So Polygon uses the same EVM. Ethereum Ethereum actually uses Ethereum virtual machine. So Polygon is built on the same thing only, but it is kind of a layer two solution, because the consensus mechanism it uses proof of stake. So it solves the so Polygon basically solves the problem of what we can of the high network congestion, because there are less entities on Polygon right now, so there is no network congestion, and the gas fees is very less. The transactions are fast, plus the network is as compared more secure to Ethereum. So Polygon, like in for a- if like what is actually happening in the market right now, people are actually building their smart contracts on Ethereum, but they are deploying it on Polygon Matic, because, as I said, it's a layer 2 solution. And but Polygon has its own cryptocurrency, which is we can say it's an ERC20 token only. The Matic with the cryptocurrency which they have. Because there are other questions. The gas fee split between the miner and the verified transaction platform on which the transaction took place. No, the gas fee is not split actually. Yeah, we can see like the gas fee. See, the miner has its own particular reward. The reward is actually fixed for each miner, and the remaining fee is the fee is gone for the network maintenance. Can you dive deeper into the mining concept of solving the hash code? See the hash code the hash code I just wanted to ask, like which hash code are you asking? Can you dive deeper into the mining concept of solving the hash code? Like, what's his name? The person like who asked this question. Can you like please elaborate this? Like what you actually want to ask?
Okay, now let's Let's
Yes,
wait for
please.
his answer. And yeah, and someone has asked about the difference between NFT and cryptocurrency.
Okay. So the major difference is like NFT is a non-fungible token and cryptocurrency is a fungible token. So for example, remember the Slam Attacks card or the WWE cards which we used to play earlier. So like at that time, each card has its own value. Like if we are having a card of John Cena or Undertaker or Rey Mysterio. Okay, so these cards have their own unique value. John Cena card has something unique of its own. Undertaker card has something unique of its own. So the same concept is with NFTs. NFTs are non-fungible tokens, mean they cannot be traded with anything, right? So each token has its own unique entity, and so that's why the digital arts are unique. So that's why they are minted into the form of NFTs. Plus, cryptocurrencies are fungible. Like if I have an NFT of Bored Ape, so there can only be one NFT of Bored Ape. So as compared to Bitcoin, so there are I guess 18 billion Bitcoins. So that's why they are fungible, means they can be traded. They are a lot in there is not one Bitcoin. There are 18 billion Bitcoin as compared to when it comes to the NFT. So that is the like the major difference between NFT and cryptocurrency. Next, what makes blockchain mining so much energy and hardware consuming? So, as I said, like the mining requires a lot of hardware and a lot of hardware energy because because when it comes on solving the nonce value, see, only a computer has to solve that particular nonce. That's why a high amount of computing energy is required to power up your computer. That's why and high energy is required and a good hardware and a good GPU is required for mining purpose. Only the miners connected to the node from where the transaction have to verify and add the block in the blockchain. No, I guess it's not a particular thing. Like there are a lot of miners and nodes in the chain, so anyone can get the chance. But it depends upon the consensus mechanism only. Every consensus mechanism has their own concept. In proof of work, it is open, but in proof of stake, it is totally different. The person who has staked a lot of ethers will get to mine the block. So that's why the network congestion is very less and the gas fee is very less. What is gas consumption? So gas consumption is
Consists
basically sorry.
nothing. Please continue.
Okay. So gas consumption is basically the gas fees, the gas fees which is used to power up that particular transaction, and the fees required to paying the miner. That's all the whole concept of gas fees. But uh, plus from a broader sense, if we see is like when it comes like on Ethereum, we get the functionality of building smart contracts, and smart contracts is basically the business logic build that we are building on the blockchain. So as we write code and we write the functions, suppose buy send functions in the smart contract, so to power up those functions also we require gas fees, because in layman terms we can say that we are just making a transaction on the blockchain only. So that's why the gas fee is also required in that purpose as well. Your opinion on NFT games? Okay, so see, NFT games is like it's a totally different concept. So uh like what opinion you want from mine on the NFT games? like um like I don't have a negative opinion for this. Like it's a very good thing which is happening. I'm not sure about hash. Just saw on YouTube the minus all the hash, and that hash is specific. That hash is the pattern thing I was asking. The nonce. So nonce is basically convert into nonce is basically a hash thing only. So the computer and the computation gets to solve that particular nonce. So nonce is basically in a form of hash value only. So should Bitcoin move to proof of stake or proof of work is unsustainable? That totally depends upon Bitcoin. Like if they want to move from proof of work, but I guess there is a limited supply of Bitcoin, so I guess they won't move to proof of stake. Zedrun is a good example. Okay, I haven't heard about Zedrun. I'll surely go through it. How double spending is eliminated in the blockchain transaction. Okay, so what happened? So double spending problem is basically the problem uh, like uh, the double spending is problem is basically solved on blockchain only because, as I said, the transaction is mutable. The transaction, once it is happened on the blockchain, it is happened. Like it cannot be retraced back, it cannot be deleted. So that's how it solves the double spending problem. Like no one can tell so as I said, there is the transparency, the ledger is open to all, and the transaction is immutable. That's how the double spending problem is eliminated on the blockchain. Do miner earns a considerable amount by mining, like a bank charging transaction? Yes, miners actually earn a very good amount. I guess on Bitcoin, if you get to mine the block, the miner gets a reward of 0.2 Bitcoin, and on Ethereum, I guess it is 1 ether. I guess I'm not right, but it is something similar to this only. So that's why a miner gets a good amount. Like mining is a very good profession actually, but for that you require a very good competition. You require a very good setup, a good GPU. Okay, rewards for Bitcoin mining a block is okay. Okay. 6.25. Okay. Okay, I guess.
I guess that's yeah. Everyone's done with their questions. I guess.
Actually, there's one request. Like, can we take a screenshot so that I can upload it on my profile as well?
Yeah,
So
sure.
like,
Yes, sir, sure.
Yes, sir.
so okay, so let me take it. Just a second. Actually, I'm not able to take the screenshot. Can you like take it? Let me take it from my phone only. Let me do one thing.
So we will take the
Or if you,
screenshot.
if you find, our team can share the screenshots with you.
Yeah, we have taken a lot of screenshots.
Okay. Okay. Okay, one more thing, just like before leaving. Uh, guys, we have this Discord server as well. If someone is interested to join like sharing this in the chat link. So if someone is like interested to join this, because as I said, like we curate educational content on blockchain. So we actually will help you guys. Like if you are interested in learning blockchain, we help you train you, and we help you with the resources and everything you want to learn blockchain. I have shared the Discord link in the chat, and you can see and you can join the community. Plus, we also have a weekly newsletter coming up, podcast, and everything. So thanks a lot, everyone. It was great. If you have any other doubts, you can ask on this Discord server. I am like 24/7 available, and I'll also share my LinkedIn link on the Discord server itself. You can contact me from there.
Thank you, sir. Thank you.
Okay. Thanks
Once
a lot.
again, we
Thank
would
you,
like to
everyone.
express our gratitude, sir. Thank you.
Okay. Thanks a lot. Thank you, everyone.
And I think this marks the end of session 1. We would like to thank our audience for the presence and support. And I hope this session would have provided you with the wealth of information on blockchain and its architecture. Our next session will start at 4 p.m. We hope to see all you guys there. And thank you again.
Thank you, everyone. So you're telling me something? Yes, sir.
I want to talk to you personal, Spurs. Can you call me
Yes,
later?
sir.
Yeah, Spurs
Yes, sir.
can
Shall
call
I?
me. Thank
Shall I
you.
call you now, sir?
Yeah, bye.
Yes, sir. Sure. Yeah. I guess, Srishti, you can end the meet.
Okay.